Hi, everyone. Welcome. My name is Lynn. I'm a Bounty Program Manager here in the Microsoft Security Response Center, and welcome to our third ZDQ training session. I'm really excited to have Jonathan here from the MSRC Vulnerabilities and Mitigations team, along with Luis, and they're here to present on access issues. And then we will have some time after the presentation to answer any questions that you may have, and then we'll also be jumping into a challenge, kind of similar to a couple training sessions ago. So feel free to use the meeting chat to ask any questions, or you can use the raise hand function in Teams and raise your hand once we get to the kind of question section. Please note that this session will be recorded. Wendy, our fantastic Wendy, will be sharing a private link to a unlisted YouTube video in the coming couple of days. And then we are super excited to have Jonathan, so I'll hand it over to you.
Awesome. Let me present. Let me know. Let's see. It looks like it's loading. Okay, can you all see this?
Loading on my end. Yep, looks great.
Okay, great. So my name's Jonathan Dutson. I work at MSRC on the vulnerability mitigations team, like Lynn said. Really excited to be here. So my team's the one that's responsible, like Michael, who you might have heard from a couple weeks ago, for looking at your cases, reproducing them, assessing them. So I get to work really closely with the work you do, and I really enjoy it. So we're going to be talking about access control issues today. And to start off, I did just want to say thank you to all of you. So I joined this team right out of college, where I had studied security, but didn't know that much about hacking. And I really wanted to learn. I wanted to learn a lot about web vulns. And so getting to see, submissions from the best researchers all around the world was an amazing way for me to be able to go from kind of like not now. So really appreciate the work that you all do. We love the partnership. So to start off, this will be a bit of a crash course. I'm sure some of you already know a ton about access control issues, but I'm hoping there'll be something for everyone. Some of you might focus on hunting for injection issues or other types of issues. So we're going to talk, it's going to be a high-level overview of access control issues. We'll talk about what they are. We'll talk about some common access control issues that we see. And then finally, like Lynn mentioned, we have an access control themed kind of CTF style challenge, which my coworker Luis and I made specifically for ZDQ, so never before been seen. So hopefully that'll be a little bit of fun. So let's dive in. To start out, just a brief slide, what is access control? So there are three main kinds of protection mechanisms that we think about when we talk about access control. So there's authentication. Who is the user who we're talking to? Once they've been authenticated, we have authorization. What does this user have access to, or what should they have access to? What shouldn't they have access to? And the third point, which sometimes is a little overlooked, is accountability. Are users able to perform actions without any sort of accountability, any sort of record that they did this? Because if not, that can lead to many issues. And there are two main things where access control issues can go wrong. So we can think about them in two ways: specification and enforcement. So with specification, we may say I'm an admin, right? And I say, oh, by default, every guest user who I invite into my organization is going to have also admin privileges. That's obviously a specification issue because we're incorrectly setting default permissions or ownership, that kind of thing. The second issue where things could go wrong, maybe I've set up my tenant perfectly properly, and I've said, guest users are going to be restricted by default. I'm not going to give lots of extra permissions to people, but maybe we aren't enforcing things properly. So even somebody with no extra permission is able to access a really sensitive endpoint. So we see those a lot as well. Now, why should you hunt for access control issues? Perhaps the most important reason you should is that they're really, really common. So broken access control is the #1 issue in the OWASP top 10. Maybe you could call it the OWASP top 1. So that's for the top 10 2021. I will say that OWASP is releasing a new top 10 for 2025, but it's not out yet. So we'll see if access control issues are kind of going up or down. But what I guarantee they will be on the 2025 as well. They're a really, really common issue. They're very high impact. There's a really wide variety of impacts you can have with access control issues. So you can have horizontal and vertical privilege escalation. You can access sensitive endpoints. There's really a lot. There's confidential data exposure. There's a lot of impact in these access control issues. There's a wide variety of weaknesses, the third point. So there's something for everybody And depending on kind of what your area of expertise is or what your skill set is, you'll be able to find kind of a class of access control issues that works really well for you. So say you're really, really good at automating stuff, right? There are going to be access control issues that work very well for being discovered through automation. Maybe you are a manual wizard and you like really love digging deep into websites and finding that stuff. There's going to be access controls issues that are going to be really good for you to find as well. And there's also a range of complexity. If you're already a real expert at access control, like there are certain things that you'll be able to find that other people just might not know how to find. And also if you've been, researching something else and now are like, oh, I want to kind of explore access control issues, there are also issues that like are really simple to find. So something for everybody here, I think you should have for access control issues. They're great. Now I have a slide here about for MSRC, how do we assess these issues when you report them to us? So the two most important things when I'm looking at a case and saying what is the severity for this is how sensitive is the data that's accessible through this issue, and then what prerequisites are needed to access this issue. So this is a screenshot from our bug bar, and so you can see like the critical severity. If there are missing access controls that are exposing sensitive data from another customer, that's going to be critical severity. And so some of these again are kind of dependent on the prerequisites. So say I'm an admin and I can access highly confidential information that maybe, technically belongs to another admin. Because I have this really highly privileged role, maybe that's going to be important severity rather than like critical because it's really hard to exploit. So those two pieces, how sensitive is the data, what prerequisites do you need, are what kind of we use to determine the severity of cases. So after that overview, we're going to talk about some of the most common issues, not necessarily like the top most common issues, but issues that we've seen at MSRC. And we're going to talk about a few ways you might find them. We'll start with kind of simpler ones, and then we'll move on to some more complex ones as we go on. So to start off, a very, very simple bug, but very, very impactful, missing authorization checks. So in this toy example here, we have Bob asking for Alice's data. There's no check at all on the server. And so Bob can get that without any sort of error. So this could be for a lot of different reasons, right? There could be a missing admin check. There could be a missing ownership check. There could be a missing privilege check. A lot of times for these bugs, you do have to be authenticated to a service to perform, to call an endpoint, right? But there's no check for role or ownership after you've authenticated. So maybe there's proper authentication, but there's no authorization. Because this is a really simple bug, you might think, oh, maybe everybody's already found it or they've already fixed it, but that's absolutely not true, as many of you know. Some of the simpler bugs are also simple to implement. There are easy mistakes. Simple bugs are pretty common. One way you might issues, like I mentioned before, you might have different areas of expertise. You might be really good at manually hunting, automated hunting. One thing we did at MSRC is we had found a few issues in this API through manual hunting, and we thought this is a kind of a API that there are probably more issues on, but we wouldn't want to spend the time to manually hunt every single endpoint in this API. And so we created this tool. My coworker Sean Hinchy create this tool called Generator, which will take an open API specification and it takes an access control or a token and will make calls to the API with that access control. So this was a way that we were able to kind of take what we learned through manual hunting, apply some automated testing to it, and find additional issues that we hadn't identified originally. So automation was a way in this case to kind of help us scale the impact. And this is open source, so there's a link to it there. You can see kind of how it works here. So you specify kind of the file with the open API specification. You can specify the token, XYZ in this toy example, and then it'll make a request to each of these endpoints. And you can kind of see, for us, what we looked for was the responses. Were we getting 401s or were we getting 200s when we expected a 401? So this is kind of an interesting way that we expanded to find additional issues. Next, we'll talk about IDOR. This is kind of a subset of missing authorization check. So in this example, user 101 is getting record 101, totally expected. Where did things go wrong? If we have no checks, and this user is also able to access record 102, record 103, record 104, there's no kind of enforcement check here, and that's a big issue. So some of you might know Cam Vincent, one of my coworkers who he hunts a lot for IDOR bugs. So he recently presented on these at NullCon, and he talked about how he found over 100 IDOR bugs at this company, helping him become a top researcher there. So they're really common. We see these bugs at Microsoft as well. So I don't think his talk is out on YouTube yet, but when it is, you can check it out. Really cool talk. One thing that I'll note for IDOR, in regards to MSRC severity, I talked about those prerequisites. So this is a really simple toy example. 101, 102, 103, they're kind of sequential, right? A lot of times IDORs are using GUIDs, which are maybe a lot harder to guess. But MSRC, we do not consider those to be like a prerequisite that like is hard to get. Unless there's a value that's explicitly considered a secret, just because it's hard to get doesn't mean it doesn't meet the MSRC bar. So if this, instead of user/101, was user/some long GUID, right, that's still going to meet the bar, assuming that the data is sensitive enough. So yeah, if there's a GUID instead of kind of a really simple ID here, still submit it to us, because we don't consider that a prerequisite that will stop kind of an attacker from exploiting this. How you might find it, there's, of course, we all love Burp. You can use Pro or Community to use kind of Intruder to iterate through. That works best for these sequential kind of bugs. And of course, manual hunting always works too. Cam does a lot of manual hunting for these IDORs, I know. So next we'll talk about path traversal. So sometimes we have an application that takes input from an untrusted source, and it's intended to go to one certain part of the file system, but because there's missing kind of neutralization of that input and you can point it to somewhere it's not supposed to access, as you see with this second arrow here. So this is an interesting one. Of course, there are a lot of different ways you can exploit it. Kind of the standard way, we've got these / forward or backslash for kind of the Linux or the Windows style. You can also try to escape characters if there's some sort of sanitization happening. You can also try URL encoding these. So a lot of ways to find path traversal. There might be mitigations in place that try to block these characters, but there are lots of ways you can get around it. So URL encoding, if the injection point for a path traversal is in a URL itself, it's kind of automatically going to be URL encoded. So where URL encoding is going to be most interesting is, say you have an injection point in a post body or something where it's not maybe necessarily going to be URL encoded. They might be on the back end doing some sort of decoding though. So you might be able to bypass checks on the front end or kind of in the protection first phase, but then in the second phase, you might be able to exploit this. Sometimes people have protections that only apply once, right? So maybe they say, oh, we're going to decode, URL decode something, we're going to run our checks on it, and then we're going to let it go through. If you double URL encode it, once you do it once, it still could bypass those checks, but then might in the back end still be interpreted as the backslash or // Another interesting way you might be able to bypass path traversal. So there are some services that will try to prevent it by removing // And one way you can get around that is put a // in the middle of another // and you remove the middle one, and now you still have that // Sometimes backends will ignore the null byte, the 00 byte. And so if you inject extra stuff in there, that maybe will bypass the detection looking for // when it's interpreted in the backend, it might still treat it as a // and allow for path traversal. And finally, Unicode encoding, another way basically you can kind of obfuscate what you're really trying to do. And these all of these kind of payloads are depending on how the backend will interpret your input, but Unicode encoding is one way. And there are many other ways. This is just kind of a selection of interesting ways you might do it. The next issue we'll talk about is client-side access restrictions. So we've got another simple example here. Say we have this admin check endpoint. It returns the set cookie is admin to false. And now when we call admin portal, you see we get a 401 unauthorized. But of course, the issue with this is that you can just change the cookie to true. This is a client-side thing that clients control. Again, a very simple example, but one that is sometimes overlooked. And cookies are not the only place you can look for these client-side access restrictions. There are lots of different ways you might do it. So for example, one thing we've seen sometimes at MSRC is you can change response headers or response bodies and see if you get different responses there. So one example, you could replace 401 unauthorized with 200 OK, see if that changes the behavior of your application. One thing I'll note about this is that just because something renders doesn't necessarily mean that there's an issue there, right? So if you change a 401 unauthorized to a 200 OK, the page might load. But again, the question is what sort of data is accessible there? So if you change it to a 200 OK, and not only does the page load, but there's data that wasn't there before that's sensitive that you can access, that's when there's going to be an issue. Occasionally, there will be client-side code that is handling some sort of authentication or authorization logic. And because that's client-side, you have full control over it. You can look at the code, look for those kinds of issues. That's another place to look for these client-side access restrictions. Like the example we had, cookies, check them for user claims. Another interesting one is feature flags. So there are kind of two maybe interesting ways to think about feature flags. One of them is if you find a product that has a feature flag that's disabled by default, you could try enabling it. And there might be functionality that maybe hasn't gone through the same rigor as something that's been fully released. So enabling a feature flag and trying to test for issues there might be a way to expose behavior that is hidden by default and that might be exploitable. Another thing that we've seen too is occasionally there'll be a kind of mitigation or like a test mitigation and a feature flag. And if you disable it, there might be interesting behavior too. You might be able to bypass a mitigation or do it in a way that's not expected. So maybe the recommendation is if you find some sort of feature flag, see if it's on or off by default, and then just change it to the non-default option and see what happens. And then finally, this is the last kind of bug we'll talk about. So we'll talk about OAuth implementation or configuration bugs. This is one, again, that like the more you deep dive into this, you might be able to find bugs that other people might not be able to find through automated scanning, for example. OAuth is really, really flexible, but that means it also allows for a lot of mistakes. It was initially designed for OAuth. The auth stands for authorization, not authentication, but sometimes people use it for authentication even still. So that's an example of like if there is a website that hasn't done a deep study in like how they're supposed to use OAuth, they might make mistakes, simple mistakes like that. There are also a lot of different kinds of OAuth flows. And so if you know the different flows, you can understand where you might look for the weaknesses in those flows. So this on the screen here is an example of the authorization code flow, which is in general a pretty secure flow, but of course there are still things that can go wrong. So how this flow works, I have maybe my app is called example app, and I'm wanting to authorize with Outlook to read contact information, something like that. So Alice signs into my example app and visits the endpoint, and she can say, Outlook, I agree that example app has permission to access my contacts. And so after that, then Outlook will return authorization code to my example app, which my example app can then exchange for a token and then use that token to call and get contact information from the Outlook API. So there's kind of a couple round trips here. Getting the authorization code is the first step. Getting the access token is the second step. So one thing that goes wrong here, even though this is in general a pretty secure flow, is example app wants to make sure that another app can't just say, oh, actually, I'm example app, but really they're evil app or something, and lie to Outlook and get Outlook to give them permissions, which really they haven't been granted. So, and that's done by the client secret. So we recently had a case where a client secret was exposed through a missing access control kind of issue. And so if you can get that client secret, now you can create your own malicious app. You can pretend to be example app and get data on behalf of the user, even though your app actually hasn't been authorized. So that's one thing to look for, even in kind of a well-implemented OAuth flow. This flow is the implicit flow. It's a lot easier to implement. It doesn't have a client secret at all. It doesn't have these it doesn't have the authorization code at all. It just gets the token kind of directly through the API. But it is in part because it is a little simpler. It is also easier to exploit. And the implicit flow is kind of discouraged by OAuth now, but it's not prohibited, and you still will find it in use places. So probably the most dangerous thing about the implicit flow is that the token is returned directly from the authorization server in the URL to the example app, right? And so two of the main ways you can exploit that is if you find some sort of open redirection bug in the example app, right? You can craft a URL and say, hey, visit this site, get authorized, and instead of returning to example app, return to example app, redirect URL equals evil.com. And now because the token is included in the URL itself, it will get exposed to this malicious website that you've redirected to. Another thing is URLs, they get logged in a lot of places. So if you're able to find a place that's using the implicit flow and they have logs that you can get access to, you can access the token through that way. So again, the implicit flow isn't necessarily vulnerable just as soon as you see it. It's just a lot more vulnerable than some of the other flows. And so you can look for these additional ways to exploit it. We've reviewed some of these in the previous slides, but just things to look for. Look for that implicit grant type which again is discouraged, prohibited in some cases, but still in use sometimes. Another thing you can look for in OAuth requests, there's this state parameter, which is used to prevent CSRF attacks. If that's missing and you're able to perform a CSRF attack, that can be pretty high impact depending on what the application is, right? So what this allows an attacker to do is you can sign in, you can have the user visit some, you can start the authentication or the authorization process, and then in the middle of it, stop, take your URL that is the next step of the process and send it to the client. And then the client will complete that and sign in to the attacker's account. And so again, the impact of this can vary, but if it's something sensitive, like say you could use this to get the attacker to sign, or the victim user to sign into Bing or something, right? Then whatever searches maybe the user makes, now I can read those. And so that can be really, really impactful. So the missing state parameter CSRF attacks can be big. Another thing to look for is maybe OAuth is implemented perfectly correct, but it just has really, really permission scopes. So scopes are basically what example app is asking for from Outlook, right? Do I want to read the contacts? Maybe that's the only thing my app is designed for, but maybe instead I actually ask for, I want full access to your account. So that can be problematic because your app really should only be, it should be following the least privilege principle, right? I should only ask for what I need and not more. And so if you see something asking for a huge scope when really it doesn't need that, that's a risk, because then if my example app, say, gets taken over, instead of just the contacts being leaked, right, it could be my whole account or a lot more data that's leaked. So you can look for scope permissive scope issues as well. And then like I mentioned too, if OAuth is being used for authentication, that can be a red flag. There is a way, because so many people were using it for authentication, they have an add-on, OpenID Connect, which is a way you can safely use OAuth for authentication. So if they're using that, they're probably okay. But if they're not using OpenID Connect and are using OAuth for authentication, that's probably a red flag. And so that's it. There's your crash course on access control issues, a lot of them that we've seen at MSRC. So now maybe I'll take questions first. We'll do this simultaneously. I think there's a link in the chat to the GitHub repo. I'll take any questions, and then we can talk about how to set up this GitHub repo and start with capture the flag. I haven't been monitoring the chat, so.
Do you want me to read that to you? Oh, you
Yeah,
can.
there's a couple
great.
great questions for you. The first one is, how does MSRC assess the severity of authentication tokens being accessible to low privileged users?
Good question. So it depends on what this authentication token is used for. So if you're a low privileged user and you're able to steal a token from a higher privileged user, right, that's going to be an issue. And then again, we take into mind what are the prerequisites required to steal this auth token. So one thing that might not require any user interaction or any special permission is an SSRF that might leak an auth token. Right? If you can point an SSRF, which is making an authenticated request, and it's supposed to be to a backend server, you point it to your own server, that's going to be serious. It might be a little harder to exploit something like a phishing attack, right? Maybe cross-site scripting, say, where you're a low privilege user, you could exploit an admin, but you have to get them to visit a malicious link. Yeah, so this is a combination again of how sensitive is the token, and then what prerequisites does the user need to get that token would be the two questions we keep forefront in mind when assessing the severity of those.
Awesome. Gerald, did that answer your question? Did you have any follow-up questions there? All right, we'll move on to the next question. Another question is, how does MSRC assess IDOR vulnerabilities when resource IDs are long, random, alphanumeric values and not easily guessable? In such scenarios, how is the severity determined, and what factors influence whether the issue is considered valid?
Yeah, great question. So like I tried to mention briefly in the IDOR slide, just because something is hard to guess, unless it's explicitly considered a secret, which usually they're not, usually these are just long IDs, then we don't consider that something nobody will ever be able to guess. Because there might be some other way that this ID gets exposed, right? Some other endpoint. So in general, if there's an IDOR and you're a user using this IDOR to access some other user's account, that usually, if it's sensitive data that's being exposed, that will usually meet the bar, even if it's a really hard to guess ID. Yeah, is that helpful?
So you mean to say that if it's not guessable, so unless and until we don't find a attack vector where we can dump those IDs, it won't be valid as per MSRC bar?
No, it'll still be valid. Yeah, you don't have to prove that this ID can be leaked somewhere else, right? generally assume that it's not a secret. And so even if you say, hey, there's this kind of hard to guess ID, but I found an IDOR where I can use it, that's still going to be valid if it's leaking sensitive data. I would say the only exception is, this isn't really an IDOR, but occasionally there will be endpoints that don't just rely on an ID, but rely on some sort of temporary authorization, either code or token or something that is intended to be a secret. So in that case, maybe, that's more of a mitigating factor, but especially with static IDs, which is what the vast majority of those are, we don't consider them to be secrets that would prevent stuff from meeting the bar.
Awesome. If anyone else has any other questions, feel free to either raise your hand or put them in the meeting chat. I think those are the 2 questions that we've had so far in the meeting chat. If you want to turn it over to the GitHub repo, and then you can answer any questions after that.
I'll just say one more thing about the GUID. A great way to test this is if you have 2 users in in a tenant, and you see they can both call this API with their own kind of GUID. If you just show us that, like, hey, I swapped the GUIDs and the users can still access the other user data when they're not supposed to, that's a great way to demonstrate it. Even if user A wouldn't have a normal way to get user B's kind of GUID. But yes, with that, let's open up the CTF. So we've got the link to the GitHub repo, and I will share my screen here. So what we'll do maybe is just walk through the beginning of the first challenge and show how to set up. And then if you have any questions, we can take those. So you can download the GitHub repo, and then it's been put in a Docker container. So you can run the commands in the README. You can build that container. You can run. And then after that, let's open up localhost. The first time you load it, you might need to just refresh the page to get it to render. So for this capture the flag, there are 5 challenges, and there are actually 4 flags. So one of the challenges does not have a flag, but there are 5 challenges, 4 flags. You can enter the flags here. Once you've completed the challenge, this will show that it's complete. This kind of lists the 5 challenges. So we'll start with the first one. We'll walk through this. So we've got this order page. There's kind of a hint as to what this challenge is about, IDOR here. And so let's open up. I've opened this in I've opened this in Burp. So I'm going to open up Burp. I'm going to use this. Let's just refresh the page and see what it looks like. So you can see we're fetching this IDOR page, and then we're fetching this order details. So this looks like maybe a good candidate for some sort of IDOR bug. And so let's test that here. So we have 215, which was our user's kind of order. What if we do 216? Yep, that looks like it's still giving us a 200 OK. Let's do another random number. Yep. So this is an example of an IDOR where you're able to access, orders from other users. And so we won't do the full challenge, but I will say, Burp Intruder might be a nice one to use on this one. So if you go here, and let's do numbers from 100 to, I guess one thing to know, if you do 4 characters, we've got an invalid order ID. So there's some sort of limitation here. But if we use Burp Intruder to kind of step through these IDs, one of those IDs will have your flag. And so that's how the first kind of challenge will work, kind of the simplest challenge. In fact, maybe let's just do it. Let's see. Let's do it through a 999. We'll start the attack. And so we've got status codes 200 on all of them. Since we're looking for a different response, and we kind of know that, let's see if we find anything different by length. Okay, so these kind of are all similar length. Here we go. So this one is a little bit longer than every other response. Maybe that's going to be our target. So if you look here, here we go. In the special instructions, there's our flag, and we'll take it to the submit the flags page. Let's enter it. Flag is correct. And now we have completed the IDOR challenge. So there's the first challenge. And then, yeah, that's how you'll play. Any questions?
I have one question.
Oh, go ahead.
So in MSRC bug bar, it says an unprivileged user accessing data intended for privileged users, which is classified as important severity. However, similar issues are sometimes accessed by design. Could you clarify what factors leads to this reason? And in my case, it was creating thousands of records in the system by low privilege user, and there was no rate limits as well?
That's a really good question. Yeah. So for my team, we a lot of times don't have a full understanding of architectures of, there are lots and lots and lots of products at Microsoft, right? So the understanding of how a product design is designed mostly comes from our engineering team partners. So if you can send us the case number, we can certainly take another look at that. But in general, like how I would go about assessing a case where I'm not sure what the design is, right? So maybe a low privilege user means different things in different products, right, at Microsoft. And so what's considered like a low privilege user in one might have different capabilities in, say, Teams than in Microsoft 365 or something like that. So what I usually do is we reach out to the engineering team to try to understand how this was designed, kind of what their security boundaries are, and that's how we come to a determination whether an action from a user is intended behavior or whether it's an issue that needs to be fixed quickly.
Thank you.
Does anyone have any other questions? Any questions about the CTF, or want to pick Jonathan's brain while we have him for a few more minutes? All right. If not, we'll go ahead and end today's session. Thank you so much, Jonathan, for the presentation, and everyone else for not only attending, but asking some really great questions. Like I said, Wendy will be providing out a link to the recording that should be coming in the next couple of days. Thank you, everyone.
Thank you all. Really appreciate it.